Hi ladies and gentlemen, today we continue with our tutorial on the topic sequence and series of numbers. In today's tutorial, we have the following two questions. The first one, the sum of the first, third, and seventh term of an arithmetic progression is 25. If the 13th term of the progression is 3 times the fourth term, find A, the first term, B, the common difference. Right? In our second question, find a set of values of x for which the series sum from 0 to infinity of 3x all over 2 plus x raised to the power r is convergent. All right, please watch all of these solutions from the beginning to the end closely because a lot of insight will be brought in all our steps that we will consider. All right, let's start. The sum of the first, third, and seventh terms of an arithmetic progression is 25. Remember again, an arithmetic progression is that type of series in which there is a common difference. A higher term is gotten from the term immediately preceding it by adding a fixed quantity called the common difference. Okay, so now they say, and any general term of an arithmetic progression, Tn, is first term. If we call our first term A, then it will be a plus n minus 1 multiplied to the common difference. This is our first term. This is our common difference. This is the general term, the expression for the general term of an arithmetic progression. Now we are told that the first term, all right, first term, T1, we have already taken it to be A. We'll give the letter A. The first term is A, and then the third term, T3, it means n becomes 3 there. All right, so it will be A, our first term, plus 3 minus 1 multiplied to our common difference D. All right, this will be A plus 2D. This is our third term. And seventh term, the seventh term, it means n is 7 in that formula. Again, our first term is A plus 7 minus 1 multiplied to our common difference D. All right, that gives us A plus 6D. That's the expression for the seventh term. Remember, we're asked to find the first term and the common difference. So you see, we are having expressions in terms of the first term and common difference. First term, common difference, first term, common difference. So logically, we should come up with equations like we see here, equations having the first term and the common difference. Two equations, because we have enough information to come up with two equations with the two unknowns, which can be solved simultaneously. Now, they say the sum of the first, third, and seventh term of an arithmetic progression is 25. All right? Their sum of T1, T3, T7 is 25. Okay? Now, what is T1? T1 is A. So, we have A plus T3. T3 is A plus 2D. T7 is A plus 6D. We are told that that gives us 25. All right, let's simplify this expression. We have A plus A, 2A plus A, 3A. So we have 3A. Then we have 2D. Everything is addition, so no difficulty. 2D plus 6D gives us 8D. Is equal to 25. This is our first major information, and so we call it equation 1. It's our first major information. The second major information is we are told that the 13th term of the progression is 3 times the fourth term. The 13th term of the progression is 3 times the fourth term. All right. Let's handle that situation. 13th term, we all know should be T13. Is 4 times, is 3 times the fourth term. Is thrice the fourth term. Okay? That's the next equation. Alright? So it's from there that we're going to get our second equation. So what is T13? Again, we use the expression for the general term of an arithmetic progression. So wherever we find n, we're going to put 13. So we're saying a plus 13 minus 1 times d plus 13 minus 1 multiplied to d is equal to 3 into t4. This time around n is 4. So we have a plus 4 minus 1d plus 4 minus 1d. So we have a plus 13 minus 1 is 12d is equal to 3 into a plus 4 minus 1 is 3d. All right. So we have a plus 12d is equal to, open this parenthesis, 3a plus 9d. All right. So we arrange everything to have a, d, and then equal to a constant. So let's bring everything from the right hand side to the left hand side. Remember, this is plus a plus 3a. Coming this will become negative 3a. So have a is already here, minus 3a. Okay. Plus 12d is already here. We're taking this 9d from the right hand side to the left hand side, because minus 9d. Now we have nothing left on the right hand side, so we have 0. A minus 3a is negative 2a. 12d minus 9d is 3d is equal to 0. All right. This gives us our equation 2. We have this equation and that equation to solve with 2 variables, so it's solvable. Okay. We have 2 linear equations to solve for 2 variables. All right. So we can use any of the methods of solving simultaneous linear equations. We can either use the elimination method, substitution method, matrix method, graphical method, whatever method. So let's use the substitution method, for example. All right. I've chosen the substitution method. Using the substitution method. Substitution method. Okay. So if I go to equation 2, I want to make a this I want to make d the subject in equation 2. All right. So using equation 2, negative 2a plus 3d is equal to 0. I want to make d the subject. I want to make d the subject in equation 2. I will not take off equation 1 because we have to come back to it. So there I have negative 2a plus 3d is equal to 0. I want to make d the subject, so 3d here. I take this negative 2a, that way it becomes positive 2a. I divide both sides by 3. I will have d is equal to 2a all over 3. All right, which I will call star. I'll call this star. All right, because I will return to this expression in order to calculate the value of d. But I will use now this expression and put in equation 1. I cannot go back to equation 2. Those are the stipulations of the rules in substitution method. So we'll now say putting in equation 1. Putting in equation 1. That means wherever we find d in equation 1, we're going to put this expression. 2a all over 3. Wherever we find d in equation 1. All right, so that gives us, this is our equation 1, 3a plus 8 into our d, 2a all over 3 is equal to 25. Okay. Yeah, we don't need equation 1 anymore. It's all right. equals to 25. So you now see the only unknown here is a. So we'll be able to calculate the value of a. All right. Here we have 3 at the denominator. It does not cancel here. So to simplify our work, we just multiply all through by 3. Multiply each term by 3 to do away with this fraction. All right. So if we do that, we have 3 into 3a plus 3 into 8 2a all over 3 3 into 25. Okay, so what I've done is to multiply each member by 3. Right, this is mathematically correct because we have respected equality. Whatever has been done to the left hand side has also been done on the right hand side, but this will simplify our work. This 3 will now cancel with this. All right, we'll no more have any fractions to deal with. 3 multiplied to 3, that gives us 9a. 8 multiplied to 2a, this is 2a, so it is 16a plus 16a. 3 multiplied to 25 is 75. All right, this is what we get. No more fractions. All right, so 9a plus 16a gives us 25a. All right, so we have 25a is equal to 75. To get a, we divide both sides by 25. 25 cancels, 25 here, 3. So the value of a is 3. That gives us the value of a, which is our first term. So in other words, we have answered the subpart A. Subpart A of our question is first term T1 is 3. First term T1 is 3. All right, so we've answered part A of our questions. Now, part B says find the common difference. Common difference is solving for D. And this is the expression that will enable us get the value of D, the common difference. So what do? We put A equals 3 in star. All right, this is our star. So this means D is equal to 2 into 3 all over 3. See, 3 cancels there. So it means common difference is 2. Okay, this answers our second part of the question. All right, our common difference is 2. All right, that does it for the first part of this question. All right, the second question says find the set of values of x for which the series sum from r to 0 to infinity of 3x all over 2 plus x all raised to the power r is convergent. This series, we're told that this series is convergent. So we should find the set of values of x for which this series is convergent. Okay. Now, what is this series? Remember, this sigma notation means we'll be adding the subsequent terms. All right. This is the general nature of a series. Okay. It means sum of this general term from R0 to N. Okay. So it means T1 plus T2 plus T3 and so on, right to infinity. So what is our T1? Our first term here is when R is 0. We should take note. When R is 0, we put R0 here. Remember, any quantity raised to the power 0 is 1. That's clear. Our second term, T2, is when R is 1. Remember, R here starts from 0. No confusion, please. R starts from 0. If R started from 1, all right, then our first term will be when R is 1. And our second term will be when R is 2. And our third term will be when R is 3. We take note. The question tells us that our R starts from 0. So our first term is when R is 0. Our second term will be when R is 1. So any quantity raised to the power 1 just gives us the same quantity. A third term is when R is 2. So it is this quantity squared. and so on. Okay. Now, this is clearly a geometric progression. Again, recall, with a geometric progression, each higher term is gotten from the term immediately preceding it by dividing or multiplying by a constant quantity called the common ratio. Okay, we all know that. So what are we saying? If T1, T2, T3, and so on are in GP, then we are saying T3 all over T2 will have the same result as T2 all over T1, which is what we call the common ratio. Okay, that's the characteristics of a GP. All right. So in this our question, we're asked to find the set of values of x for which this geometric series converges. All right. For convergent geometric series, for convergent series, this condition must hold. The absolute of the common ratio must be less than 1. So we need to find the common ratio in this our series. We need to find the common ratio and then solve for the set of values of x for which this inequality is valid. That is the work that we need to do here. So what is the common ratio? That's the expression of the common ratio. We either take third term divided by second term, or we take second term divided by the first term. It's going to give us the common ratio. Okay, so if we take, for example, the third term divided by the second term, all right, our r is T3 all over T2. If we do that, we're going to have 3x all over 2 plus x, all of this squared, divided by 3x all over 2 plus x. Okay, so what is our common ratio? This is a fractional expression divided by another fractional expression. We all know we maintain the first fraction, 3x all over 2 plus x, all of this squared. Then we change this to multiplication and we invert the other one. It becomes 2 plus x all over 3x. Okay, so this quantity is squared up there, so one of it goes, so I left with 1. This one is also squared, this one cancels, one of it is left. So we end up with r equals 3x all over 2 plus x. So that gives us our common ratio. Our common ratio is 3x all over 2 plus x. So for the series to converge, that condition must hold. And if this condition holds, then we can get the set of values of x for which the condition holds. All right. So absolute r less than 1 is the same thing as saying -1 less than r less than 1. We all know this property for inequalities. If this, then this inevitably. So this is the inequality we have to solve here. So we're solving the inequality -1 less than 3x all over 2 plus x less than 1. All right. How do we solve such inequality? Well, we split it into 2 at the level of the middle member. This middle member go with this left hand member. The same middle member go with that right hand member, and then we intersect our solution set. So let's split it. Okay, that simply means we have -1 less than 3x all over 2 plus x intersection 3x all over 2 plus x less than 1. All right, now let's solve this. Let's take this one later on. We'll take that one. We'll look at this. This is rational inequality. We don't make the error to cross multiply. It's not allowed because we don't know the sign of this expression at the denominator. We don't know the sign. We know the sign of 2. 2 is a constant, it's positive, but we don't know the value of x. Okay, we don't know the value of x. Remember, with inequalities, if you are cross multiplying with a negative quantity, it will affect the inequality sign. So to be on the safe side, we just take this quantity here, this -1 from the left hand side to the right hand side. All right, so we now have 0 here, less than, this is -1, going that way become +1. All right, intersection. We're going to solve that one later. All right, so this means 0 less than, we handle this. This is a fraction. We can also make this one a fraction so that we see our LCM is 2 plus x. Okay, so 2 plus x divided by itself is 1. Multiply to 3x is 3x plus 2 plus x divided by 1 is 2 plus x. Multiply to 1 is 2 plus x. So we are saying we have 0 less than, arrange this up there, we have 3x plus x, 4x, 4x plus 2, all over 2 plus x. Now, from here, we have to look for our critical values. What are critical values? The values that will render the numerator 0, denominator 0. Okay, so what are the critical values? Okay, so we say critical values. Our critical values, we set the numerator to 0. That gives us our first critical value as well, it means 4x is equal to -2. When we take that one that way, it means we divide both sides by 4. It means x equals -half. This is our first critical value. Second critical value, we also set the denominator equals 0. This, when we set the denominator equals 0, it means x equals -2. This is our second critical value. So we have x equals -half and x equals -2 as our two critical values. So we carry out our analysis on the number line. On the number line, we have -2 is smaller, it comes first, and then -half. We have 1, 2, 3 zones to test values. And we're going to test our values on this expression. On the expression, we're testing the values on the expression. We're testing our values on the expressions. The expression should be 4x plus 2 all over 2 plus x. All right, less than 0. So, or if 0 is less than this, it means this should be greater than 0. Okay, the expression that we had earlier, 4x plus 2 all over 2 plus x greater than 0. Okay, so we're testing values here to see which one will be give us greater than 0. We know that greater than 0 is positive. So let's take a value from here, -3. We're interested only in the sign. 4 multiplied to -3 is 4 multiplied to -3 is let's make a small box here to be doing the work. 4 multiplied to -3 is -12 plus 2 all over 2 plus -3, 2 plus -3, so have -10 all over -1. Negative divided by negative, positive. So here we have positive. Take a value in this zone between -2 and -half. -1 is there. We can see clearly -1 is in that zone. So we put -1. 4 multiplied to -1 is -4 plus 2. 2 plus -1. So we have -4 plus 2 gives us -2. All over 2 minus 1 is 1. So we have negative divided by positive, negative. Next, we take a value in this zone. We can take 0. 0 is clearly in this zone. So we have 0 here plus 2 all over 0 there plus 2. So we have plus, plus, plus. Okay. So this is what our linear analysis has given us. Okay. But we're going to be interested only in the zones where we have results greater than 0. Greater than 0 means positive. So our solution set lie in these zones where we have positive. So for this left-hand side, let's write it here. Solution left-hand side. Solution will be all values to the left of -2. So it will be all x less than -2, or all values to the right of -half. Okay, that's the solution of the left hand side. Now let's consider this right hand, or we'll call this right hand. We're just saying right hand with respect to the intersection. All right, let's take this other inequality and analyze. Now let's call it right hand side. Inequality 3x all over 2 plus x less than 1. Again, we don't cross multiply by this denominator because we don't know the sign of this quantity. Why don't we know the sign of this quantity? Because we don't know the value of x. So we don't take the risk of cross multiplying. So all we need to do is to take this one from the right hand side inside here. So that gives us 3x all over 2 plus x. This is positive 1. Coming this way will become -1 less than 0. All right. This is also a fraction as such. LCM 2 plus x. 2 plus x divided by itself is 1. Multiplied to 3x is 3x. 2 plus x divided by 1 is 2 plus x. Multiplied to -1. It becomes negative into 2 plus x less than 0. Pay attention to this in parentheses. If we don't put this parenthesis, we'll get everything messed up. This negative has to affect every member in that expression. So we'll put it in parentheses. That parenthesis is very important. If you omit the parenthesis, then the negative will affect only the 2 and it will not affect the x. Right? Very, very important. So we simplify. So have 3x, open this parenthesis, -2 minus x all over 2 plus x less than 0. So 3x minus x is 2x. We have 2x minus 2 all over 2 plus x less than 0. Okay, so we'll now get the critical values. Again, we set the numerator to 0. So we see that our first critical value will be 1. All right. We also set the denominator to 0. We see that our second critical value is -2. So we have the critical values -2 and 1. Now, let us carry out our analysis on the number line. Same type of analysis that we did earlier. Let's do it on the number line. Now, -2 is smaller and +1 is bigger. We're working on the expression. This is the expression we're working on. We're working on 2x minus 2 all over 2 plus x less than 0. So we'll be taking values in each of these zones and we test, and we are interested only in the sign. Let's take a value from this zone. For example, -3 and put there. 2 into -3 minus 2 all over 2 plus -3. This gives us -6 minus 2 -8 all over 2 minus 3 -1. 2 minus 3 is -1. Negative divided by negative, positive. Let's take a value in this zone. Clearly 0 is a good value to take in this zone. So we'll have 0 here. We're left with -2. We'll have 0 here. We'll have +2. Negative divided by positive, negative. Let's take a value here. For example, 3, 5, 10, any number greater than 1. So let's take 3 for example. we put there, we're going to have 6 minus 2 all over 2 plus 3. This gives us 4 all over 5, positive. Okay. These are the signs of the different zones that we obtain in this case. But we're interested in less than 0. Less than 0 means negative. So our solution lies in this segment. Or this interval of values. Okay. So for our second or our right hand side, like we have called it earlier, this right hand side, solution right hand side. Solution right hand side will be all values of x between -2 and 1. So say -2 less than x less than 1. Okay. All right. So we have this solution and this solution to intersect. Pay attention. We have to intersect to get now the general solution set. So we take this solution and we intersect with this solution. How is that done? Let's do it now using a bigger number line. So I'll see things clearly in diagrammatic form. We have this number line. So we have the values -2, -half, and 1. So we have -2, -half, and +1. This value, and this value. This is still -2, so this value. All right. In the first solution, it says to the left of -2, without including -2. So we put an open circle. That means -2 is not part. To the left. And then the other one says to the right of -half. To the right of -half without including -half. So open circle. This is a strict. If it were the non-strict inequality, then we'll shed it. But it is the strict inequality. So to the right. Okay. Now the other solution says between -2 and 1. Between -2, let's take it up. Also open circle because it is the non-strict. If it were like that, then we'll shed it to mean that this value is part of the solution. But it isn't the non-strict, so it is the strict inequality. So we should take note of that difference. So between -2 and 1, also open circle. 1 is not part of the solution. All right. So where do we have intersection in those two solutions? Where do we have values valid for the left-hand side and also valid for the right-hand side? These values here, they are not valid for the right-hand side. These values here, the values this way, they are not valid for the left-hand side. Okay? But look at these values. These values here, they are found inside the first one and also inside the second, right? So this is where there is perfect intersection. All right? This is where there is perfect intersection. That's where we have a general solution set for the two inequalities. And so, conclusion, solution set will be all real values of x such that, how do we write this? -half strictly less than x strictly less than 1. This gives us the set of values of x for which that series will be convergent. All values of x within this interval will make that series converge.